everybody. So I'm here working on part 2, and I just thought I would make a quick video, give you a little bit of a teaser, some of the things that we're going to be going into in part 2. I'm going to get pretty deep into the function of these deep lymphatic vessels, since we are talking about the lymphatic system and how it relates to the digestive system and the organs of the digestive system and the abdomen. So it's really important to understand how these vessels function. So I've really gotten into studying it deeper and deeper and trying to get as much research and papers behind my thought process when I put together these protocols for you. So keeping in mind that I've been doing these protocols for many years, knowing that they work, just kind of intuitively putting this together. And over time, it just turned into this really great sequence of manual techniques and assessments and protocols. Okay. So we're going to talk a little bit about something called Mechanotransduction. Now, I just broke up the word. It's not usually hyphenated, but I wanted to kind of break it up for you. So we have something called mechanotransduction. And this is a process of how the body creates these contractions within the vessel walls to facilitate flow. So many of us learn in MLD or in some of the lighter touch modalities that the vessels do not have muscles and that the only way you can really stimulate lymph is to actually mechanically stretch the skin and push the fluids, which is very true. In order to facilitate movement of fluids in the extracellular space, in the interstitial space, you need to get it into those lymph capillaries. And that pressure really does help. That really light touch stretch does help to push that fluid into the lymph collectors. But once we get into the abdomen and we get into these deeper vessels, we're dealing with something called mechanotransduction. And in cellular biology, mechanotransduction is any of various mechanisms by which cells convert mechanical stimulus into electrochemical activity. So you guys have electrical activity in your body already. That's what the metals in your body do, particularly calcium, potassium, magnesium, convert electrochemical activity based on this stimulus. And it's a mechanical stimulus, which is why your hands are so valuable, why movement is so valuable, why pressure change is so valuable when you're dealing with the lymphatic system. So this form of sensory transduction is responsible for a number of senses and physiological processes in the body, including proprioception, touch, balance, and hearing. Okay, so there's stretch receptors in all smooth muscle. There's stretch receptors in all of the vessels. This is how the body gets its message to contract and to stimulate that contraction of those muscles that are inside the vessels. So the basic mechanism of mechanotransduction involves converting mechanical signals into electrical or chemical signals. And this is what's happening throughout your body. Okay, every cell contains an electrical charge, and in order to get that cell to function properly, you need to create these signals in order for the muscles to contract and for movement to happen. So, lymphatic adaptation to mechanical forces, which is mechanical transduction in lymphatic vessels. Here, the lymphatic endothelial cells, which are the cells on the inside of the lymphatic walls, also adapt to pressure changes, including intra-abdominal pressure, increase and decrease in extracellular fluid, and atmospheric pressure changes. So these endothelial cells will adapt and change based on the pressures that are put upon it or taken away from it. And generally, you're going to have a decrease or variability in pressure inside the body, outside the body, through the abdomen, through fluid exchange, over excessive fluid, not enough fluid. There's many things that will influence the function of these vessels. And so in this case, we're talking about the endothelial cells, which are the cells that line the vessels. The endothelial cells in a lymph capillary or in the precollectors actually open and close to let more fluid in. And that feedback is coming from the pressure inside the vessel and outside the vessel. And so that is how the endothelial cells are going to work to let that lymph fluid in. You're dealing with people who have surgery or injuries or anything that wipes out, a big stack of vessels, and the vessels have to regrow. This is one of the factors that we have to look at. Are there pressure changes in the atmosphere? Are there the vacillation between pressure inside the body and inside the vessel to help stimulate the growth of new vessels? And I think that's where scar tissue and tissue restriction comes into play. You don't have either. You don't have an increase or a decrease in pressure. You don't have a change in movement. You don't have a stretch factor involved. And so those lymph vessels just don't grow. So these changes can enhance lymphatic pumping and can also help maintain fluid balance under varying pressure conditions. So in a normal situation, you get lymphatic pumping and you help maintain fluid based on this adaptation and this of mechanical forces through mechanotransduction. Okay, so this is that chemoreceptor, mechanoreceptor, electrical potential of the cells. All of this is happening inside of our bodies at a microscopic level with these vessels, these tiny little vessels. So when you change altitude, barometric pressure decreases, which can alter fluid dynamics and pressure regulation within the body. What's also interesting, a side note on there, when the barometric pressure decreases here in Florida before we get a storm or before a hurricane comes, we have people that do have lymphedema or lymphatic compromise, and I'm there included, will actually start to have increased swelling or decreased fluid regulation in your body, which is why if you have sinus issues, you may get more headache, a pressure headache, maybe you get more joint pain because the barometric pressure decreases and it alters the fluid dynamics in the body. So the lymphatic system, particularly the thoracic duct, may be affected by these changes due to its reliance on pressure gradients to transport lymph effectively. So once your body has its pattern, it's used to the rhythms of the body, it has a pattern that it moves, and then all of a sudden there's a change. And it does affect the body's ability to transport lymph effectively. Keeping in mind that pressure inside and outside the body affects lymphatic flow. When we start to implement the protocols, it's important to understand that when you create a pressure change, you create, not only are you shifting fluids, but you're also creating changes within these vessels. Now, the lymph collecting vessels are larger vessels, and they do create they need a little bit more feedback. They're not quite as delicate as those the lymph capillaries, and they do need more feedback and more stimulation to create the pumping. Okay, so if you have something that's interfering with that movement and that pressure, then you're not going to get the pumping that you're looking for. So the layers of the thoracic duct. So the wall of the thoracic duct has 3 layers: the intima, the media, and the adventitia. It also has a basement membrane. The media is composed of smooth muscle and connective tissue. So you have smooth muscle in the thoracic duct and you have connective tissue in the thoracic duct. The thoracic duct being the largest lymphatic vessel in the body width-wise, and it's still smaller than a cocktail straw. So it's very, very tiny. It's about the width of a really small cocktail straw. In any case, the smooth muscle contracts regularly to move lymph upward or forward. The thoracic duct also contains valves, which may be unicuspid, bicuspid, or tricuspid, but are usually bicuspid. So you guys, there's some variances between people. We're all different. Isn't that crazy? At the junction of the lymphatic and venous system, the bicuspid valve prevents venous backflow into the lymphatic system. So we have a very strong valve at that terminal region where the lymphatic system meets the venous system. Obviously, we want lymphatic system going into the veins. We do not want blood backing up into the lymphatic system. All this information I got here is from this article down here. I am giving you guys a list of PubMed references on your class page. So you can always go ahead and read these articles in length. They're quite lengthy, actually. So this is where we talk about the Valsalva maneuver. This significantly affects the thoracic duct, primarily by increasing intrathoracic pressure, which can compress the duct. The compression temporarily reduces lymphatic flow through the thoracic duct, causing a temporary enlargement of the duct's diameter due to fluid buildup. This response is often studied using imaging techniques like endoscopic ultrasound or Doppler sonography, which reveal how the maneuver-induced pressure causes dilation, impacting lymph movement through the thoracic duct. This is going to be important when we're talking about breathing. This is going to be important when we're talking about different techniques that I'll teach you in part 3 that are going to help improve the flow. So once we get in and we get things moving in the abdomen, we get things moving through the digestive system, and we're pushing all that lymph up, that thoracic duct has to move all that lymph. And we're going to want to help facilitate that, right? We're going to want to support that system. And I'm going to finish off here, and this I don't want to give you too much, right? Because some of you guys have to take the class. But this kind of leads us to where manual therapy can enhance lymphatic function by stimulating the mechanotransduction pathways. Techniques like gentle pressure, rhythmic movement can create mechanical forces that activate lymphatic endothelial cells and promote fluid movement throughout lymphatic vessels. So you're stimulating not just the contraction, you're also stimulating the arrangement of the cells, you're stimulating the regrowth of the cells, and in some cases you're stimulating the growth of new lymphatic vessels through lymphangiogenesis. This is really important, especially with post-surgical clients or people who've had scar tissue for a long time. And once you can free up that movement, all of a sudden you can start to get new lymphatic vessels growing into the tissues. So you can cut down on that fibrosis, and you can cut down on that lymphatic compromise that's occurring with your clients after surgery. By mimicking natural pressure and flow variations, manual therapy supports the lymphatic system's response to pressure changes and can improve drainage and immune transport, especially in areas affected by fluid buildup or compromised lymph flow. So the whole idea here is that even though the title of the course is Digestive and Lymphatics, you have to understand that everything works in combination. So if somebody's having issues with their digestive system, or if any of the organs or supportive organs of the digestive system aren't functioning properly, it could be because there's a lymph backup. And that lymphatic flow, if it's not moving fluid and you get a backup of the fluid, it affects everything. It affects digestion. It affects the function of the liver. It affects the function of general health. And then if you move south into the lower extremities, you're dealing with someone who's trying to heal from surgery. It's only going to back up the flow even more and affect the immune function. So we're not just dealing with digestion, we're dealing with everything that has to do with digestion. The gut is a second brain. The gut is telling the immune system how to function. So this is really a whole body treatment, even though we're technically working on the lymphatic system and the digestive system. So I am looking forward to continuing working on this. I'm putting the finishing touches on part 2 this week. It'll be ready mid-November. My students are just now getting their manuals for part 1, which is their pre-study. Part 2 is going to be 8 hours, guys. Started out as 4. It's going to be 8 hours long. 2 hour. There'll be 4 2-hour modules in this class. And this is going to get us prepared for part 3. So I hope to see you guys there.